Yay, the last part of organic chemistry is here. Part 3 is just with organic reactions, and we are only going to talk about like 10%, 5% of all chemical organic reactions in the entire world. So don't worry, it won't be long. So I'll remind you of this. I talked about this in the first one. They're typically very slow reactions when we talk about organic reactions. They also have a lower yield of product due to the fact that there are many reactions that can occur in a vessel, in a reaction vessel. And a lot of times there are a variety of other things that are going to be reacting and taking away from that product you want, taking away from that reaction you desire to happen. So other things are made, and the organic product of interest just is you have a lower amount that you're producing. So the types of reactions that we'll only talk about are addition reactions, substitution reactions, and then combustion reactions. And you already know about combustion reactions, so that'll be a review. With addition reactions, you have to start with an alkene or alkyne. So that means you start with a double bond or triple bond. And because double bonds and triple bonds are taking up extra space for other things that to be attached to the carbon, we're actually going to boot those double and triple bonds out. We're going to eliminate them, and we're going to add something to that spot because there's now an open space. So let me demonstrate a little example here for you. You've got your bromine gas, which is diatomic, which is why it's Br2, and then you've got a double bonded carbon chain here. So you've got and what happens is the double bond will be broken, and you'll end up with CH2, and the Br bromine has broken apart and been added to each side. So your end reactant or product looks like this. It is now singly bonded all the way around, and the bromine has taken the place of the open spaces there. And you don't have to draw the structure. You can just write it as this with the simplest way, just the compact form. Another example of an addition reaction is one with chlorine. It's also diatomic, so you write chlorine gas this way. And whenever you're given C2H2, you may not know, but this is a triple bonded substance. And if you draw it out with your, knowing your valence number of electrons and all, you can get that triple bond. This question says it's excess chlorine. So you've got a lot of chlorine that's available to be added to ethyne, which is your triple bonded carbon chain. All that chlorine is going to break apart as many bonds as possible to make all single bonds around those carbons. So your excess chlorine, you've got plenty of it. So whenever you break this right here, when you break two carbon bonds, you've opened up you've got an empty space here, empty space here, empty space here, and an empty space here. Therefore, chlorine is going to take all of those empty spots after the double bond or triple bonds have been broken apart. Therefore, you've got C2H2Cl4. So if you don't know how to write the triple bond, you need to practice with drawing your structures as well. You will most definitely probably see this on the reaction prediction part of the AP exam. This is why I want to introduce you to some of the word reactions and then writing the reactants, and then thinking about it, how you're going to write out the products. And so that's why I'm giving you multiple options, because you could write this and it is fully acceptable as long as everything is balanced. You just put a 2 in front of that Cl whenever you do your reaction predictions. The second type of reactants or organic reactions are the substitution reactions. And all it is you're substituting an atom or multiple atoms. So one atom is going to be replacing another. The very common type are having halogens included, and they're going to be replacing something on the alkane chain. So whenever you talk about this, methane, it has 4 hydrogens around it, and chlorine, just one of these chlorines from this diatomic chlorine, are going to bounce and boot out one of those hydrogens. So it's going to substitute. So then you make one chlorine existing on the carbon chain plus this lonely chlorine that is now bonded with the H, which it booted off. So that's our hydrochloric acid that's also being produced. It's just everyone's trying to make bonds because bonding is a energy lowering process, and that is good because everything wants to get to the lowest energy possible. You can also have cycloalkanes included. So we talked about benzene in our last lecture. Here's benzene. It's the hexane, or it's not hexane, but it's hexane in a circle. And we've got double bonds on every other bond. And I didn't tell you this last lecture, so I'm going to draw it here. These H's, hydrogens, are just hanging off the benzene ring. So the double bonds are strong. That cycloalkane is very strong. That ring structure does not want to be broken. But those hydrogens are susceptible to change. So you've got Br2, and the bromine is not going to break through the cyclohexane or hexane here, but it is going to pick off one of those hydrogens and create a different type of benzene. I probably changed the double bonds up, but that's okay because it doesn't really matter. It can be written in many different ways. So we've had a bromine take place of one of those hydrogens, and then that hydrogen will bond with the leftover bromine from the diatomic bromine to make hydrobromic acid. Lastly, combustion reactions. Combustion reactions are just like we've learned before, but I'm going to talk about incomplete as well. So the one that you know about are complete combustion reactions. All hydrocarbons react with oxygen, or they just decompose if they contain oxygen in them and make CO2 and water. If it's incomplete, and you see incomplete any single time, especially in reaction prediction, they may trick you up and say there's incomplete combustion of X compound. It's going to make carbon monoxide. CO, not carbon dioxide, which is CO2. So always, no matter what crazy reactant you are given, it doesn't matter. It is going to make, if it's complete combustion, carbon dioxide and water, and you get points for those products. So even if you don't know what the crazy organic compound is, put the products down and you will get half points probably. And if it is incomplete, you're going to have to make sure you remember carbon monoxide. So congratulations, you have finished your introductory course to organic chemistry, and hopefully you learned a lot, and ask me questions as you need to.